Today we're going to get started on quadratic equations. The standard form of a quadratic equation is ax squared plus bx plus c. We've learned two techniques now to solve this type of equation. Both have limitations. The first is the factoring method, which we've been doing for a while. And the limitation of that method is that only works if the solutions are rational. The second method that we've used recently when solving equations using the Pythagorean theorem is by taking a square root. That method only works if in standard form the b coefficient of the x term is 0. Let's try that technique in an equation that can be solved both ways. So in the example 1a, we have an equation 25x squared minus 49 equals 0. If we're going to factor and use the zero product property, we need 0 on one side. That's already happened. And then we need to factor 25x squared minus 49. That factors into 5x plus 7 and 5x minus 7. So using the zero product property, 5x plus 7 is equal to 0, or 5x minus 7 is equal to 0. Solving, we get x is equal to negative 7/5, or x equals positive 7/5. So our solution set has two numbers in it, negative 7/5 and positive 7/5. In B, we'll use a different method to solve. We'll use the square root method. In order to use the square root method, we're going to take and isolate our variable term on one side of the equation and our numerical term on the other side, or our constant term on the other side of the equation. The second thing that you can do is just undo the operations surrounding x in inverse order. So in order to uncover x, we'll divide through by 25 first, and then we'll take a square root. Now the important thing to remember is that when you're taking a square root in an equation, there are two solutions. There are two numbers that squared give you 49 over 25. Those are plus or minus 7/5. If you want to think about what happened here, we have plus or minus the square root of 49 over 25. So our solution set is the same. It includes negative 7/5 and positive 7/5. Whenever we're solving an equation, it's important that you remember that in a quadratic equation, there are usually two solutions, negative and positive. Can you think about an instance in which we might only have one solution? All right, in the problems below, try these. So pause the video, and then when you restart the video, I will show the solutions to these problems here. All right, here is the solution to problem number 1. If you want to pause the video, then I'll show you the solution to problem number 2. Here is the solution to problem number 2. Pause the video and wait for the solution to problem number 3 after you. Here is the solution to problem number 3. Try problem number 4, pause the video. Here's the solution for number 4. Pause the video and try number 5. Here is number 5. Pause the video and try number 6. Here is the solution to number 6. Pause the video and try number 7. Here's the solution to number 7. Pause the video and try number 8. Here's the solution to number 8. Notice that this equation has no real solution because there is no number that when squared gives you a result of negative 4. We can also use the square root method for equations that are in the form an expression squared equals a number. And in example 2, we see that sort of equation in part A. So in order to solve this one, we're going to undo the squaring. If we undo the squaring, we get x minus 4 on the left side. If we undo the squaring on the right, we get plus or minus the square root of 9. So now let's separate that into two equations. X minus 4 is negative 3, or x minus 4 is positive 3. If we solve each one of these equations by adding 4, we're going to get solutions of 1 or 7. In B, we see a similar sort of a format, so we're going to unsquare. M plus 1/3 is equal to plus or minus the square root of 4/9. So separating into two equations, m plus 1/3 is negative 2/3, or m plus 1/3 is positive 2/3. Now we're going to subtract 1/3 from both sides. Negative 2/3 minus 1/3 is negative 3/3, or negative 1. 2/3 minus 1/3 is 1/3. So we get two solutions. In example 2c, we'll employ a similar method. Unsquare both sides. And so two equations, 1/5 y plus 7 is equal to negative 11, or 1/5 y plus 7 is equal to positive 11. Subtracting 7. And then multiplying both sides by 5, we get two solutions, negative 90 and 20. In D, we can employ the same technique, unsquare both sides. But here we're taking the square root of a negative number, which is not real. So we can stop right here and say that there is no real solution. Bear in mind that we're not going to say there is no solution at all, because in Algebra 2 you will learn how to find the imaginary solutions of this equation. In example 2e, we can use the same procedure, unsquare both sides, and that gives us a minus 4 is equal to plus or minus the square root of 7. Now you'll notice that the square root of 7 does not simplify. That is to say, it's an irrational number. So what we can do is separate this into two separate equations. And add 4 to both sides. We get two solutions, 4 minus the square root of 7 and 4 plus the square root of 7. Notice that those solutions cannot be simplified because we can't add the unlike terms. In example 2f, a similar procedure. Take the square root on both sides. In this case, the square root of 45 simplifies into 3 times the square root of 5. So u plus 2 is either equal to negative 3 root 5 or 3 root 5. Subtracting 2 from both sides. So we get two solutions, negative 2 minus 3 root 5 and negative 2 plus 3 root 5. Try the problem below, pause the video, and wait for the solution. Here's the solution to problem number 9. Pause the video and try 10. Here is the solution to number 10. Pause the video and try 11. Here's the solution to number 11. Pause the video and try number 12. Here is the solution to number 12. Notice that in this one, since our fractions both have common denominators of 4, that we can combine them together into one big happy fraction. In other words, when we subtract 1/4, we can actually add those two fractions together and get the results in the solution set below.